I'm glad to welcome you all back to the first lecture of the Batavia Windmill Symposium, which is also the 23rd lecture in the New Lyceum Lecture Series. Welcome to the American Windmill Story. We'd like to thank the Chronicle for co-sponsoring today's lecture and the Batavia Public Library Foundation for sponsoring the 2013-2014 season. Before I introduce our speaker, I'd like to remind everyone that cell phones should be set to silent, please. Today, I'm delighted to introduce our speaker, the world's leading expert on American windmills, Professor T. Lindsay Baker. Dr. Baker comes to us from Rio Vista, Texas. He's the W.K. Gordon Endowed Chair in Texas Industrial History at Tarleton State University, where he's also director of the W.K. Gordon for Industrial History of Texas. He's the author of more than 30 books, which include The Field Guide to American Windmills, a Bible of windmills if ever there was one, Blades in the Sky, and The Beautiful American Windmills, an album of historic photographs. He's also the editor of the long-standing Windmiller's Gazette, and a gracious answerer of any windmill question, whether it be large or small. Please join me in welcoming Dr. T. Lindsay Baker.
Thank you, Ms. Peterson. It's a real pleasure to come back to Batavia. I first came here for research in the summer of 1977, and I keep returning to the Mecca for wind power history in America, because if there is a Mecca for windmill people, we are in that place. I'm going to talk a little bit about the context for why we're here. We're going to talk about American windmills, their manufacture, their use, and I'm the warm-up band for the afternoon speakers who are more effectively than me going to talk about why Batavia is important in the wind power past of the United States. If someone would be so kind as to dim the lights. And we're beginning with a photograph made from just about where we're seated right now. We've all gathered here on the banks of the Fox River to explore the place of Batavia in the history of wind power development in America. This city played an instrumental role in the early days and later expansion into the 19th century growth industry of windmill manufacture. Mass-produced wind machines from Batavia once dotted not only the rural landscape of America, but also much of the world. This is a Halliday standard on a cattle ranch in Australia. Batavia made wind machines, pumped water, ground grain, sawed wood, chopped livestock feed grains for people around the world. It was here along the Fox River that some of the most important technological developments in wind power took place and helped our foreparents learn that the renewable power of the wind could be their reliable partner. My role in today's events is to place these contributions of Batavia into the broader context of wind power history. The windmill is fondly recognized as a feature of the American landscape, a sentinel rising above rooftops and fields. Its stalwart presence states clearly that human ingenuity has been at work. From the earliest days at Atlantic coast settlements, immigrants built European-style windmills for grinding grain, a technology familiar in the Old World. By the 1850s, American inventors developed smaller wind machines, appealing to farmers and livestock raisers. An entire industry developed, mass-producing factory-made windmills by the hundreds of thousands. These machines eventually appeared in all parts of America and were exported to markets around the world. During the 20th century, newer machines joined the ranks of those producing mechanical power. These generated the modern miracle, electricity, for homes, shops, and streets. Today, both windmills and wind generators remain on the market, filling a niche of using free energy in areas not accessed by electrical power grids or in places where consumers prefer using natural sources of power. This is not to mention the use of large wind generators as producers of power used in larger areas. Windmills first appeared in the present-day United States in the 1620s. English immigrants erected them first in Virginia and then in multiple locations along the Atlantic coast as well as inland, while French-speaking immigrants built windmills in what became Canada. These traditional Old World windmills usually had 4 blades covered with canvas sails, and they had to be directed manually into the wind. European-style windmills worked satisfactorily for the purpose of grinding grain for communities, but they were large and expensive. Most farmers or livestock raisers could never dream of owning such machines. What they needed was small wind machines for grinding limited amounts of grain or pumping water. As early as 1833, James Kerr in Maury County, Tennessee, patented an early wind pump for small-scale use. This is the stylized drawing that accompanied the patent application. Apparently, it was unsuccessful. It swiveled to face changing wind directions, but did not control its speed of operation. What was needed was a windmill that was self-governing, one that would automatically swivel to face the wind and would control its speed of operation without human attention. When a wind wheel turns too fast, it either burns up its bearings or it tears to pieces from centrifugal force. A New England Yankee, Daniel Halliday, in 1854 came up with the first design for a self-governing American windmill that proved to be commercially successful. He and other capitalists organized a company in South Coventry, Connecticut to produce the wind machines. It actively promoted their sale in state and county fairs and in periodicals read by progressive farmers. John Burnham, Halliday's partner. The company sent him in 1857 to Chicago, where he found a substantial market on the Midwestern prairies and on the eastern fringe of the Great Plains. The expense and delays of shipping windmills from Connecticut to Illinois led the company in 1863 to move its manufacturing operation to Batavia in the Fox River Valley, the place that you've learned had both water power and the advantages of railway connections. Right here, just west of Chicago. I may need some assistance from someone. And here's the lady in turquoise. She is the assistance. And that's just where we want to be. And you can slap my hands afterward. From this library building, we can look down on the site where these events transpired. There, the company operated as the U.S. Wind Engine and Pump Company from the 1860s into the 1940s. Other entrepreneurs on the plains and prairies saw the market for windmills. And starting in the 1870s, substantial numbers of them opened factories. Once the U.S. company brought windmill manufacture to Batavia, it subsequently was joined there by other firms, like the U.S. Wind Engine, the Challenge Windmill and Feed Mill Company, the Batavia Windmill Company, the Appleton Manufacturing Company, and individual makers like Benjamin Danforth. In the meantime, consumers in the East recognized the advantages of windmills. As did others on the Pacific coast. Through the 1880s to 1900s, windmills represented a substantial part of the farm implement industry in the United States. Trade journals like Farm Implement News and Implement Age carried regular articles on windmill manufacturers and their products. And farm newspapers like the American Agriculturist and Hoard's Dairyman carried advertisements directed at potential buyers. Probably due to the influence of Western novels and motion pictures, windmills are associated with ranching. This is valid because windmills by the hundreds of thousands made it possible for humans and their animals to live in the arid West. Properties like the storied XIT Ranch in the Texas Panhandle use windmills by the hundreds. done something embarrassing. There's a off switch on the side of that. Thank you so much. I apologize for that additional interlude. Ranchers bought thousands of windmills, but farmers purchased even more. All over the United States, but especially in the West and Midwest, agriculturists used the power of the wind to bring up groundwater that otherwise would have had to have been pumped by hand. In areas with comparatively dense population, such as Illinois and the lower peninsula of Michigan, windmills were used in vast numbers. Almost every small farm that did not have naturally running water had at least one well with a windmill. Farmers who could not afford a windmill wished for one. Railways required reliable supplies of clean boiler water for their steam locomotives. In areas without surface water, companies as early as the 1860s sank wells, installing over them sometimes huge windmills, like this Batavia-made Halliday Standard. Wind machines pumped water into large elevated tanks fitted with spouts that could quickly fill locomotive tenders with fresh water, just as Mr. Schust explained. Windmills found application in urban areas as well. In some instances, windmills pumped groundwater into reservoirs, providing water supplies for entire towns. Individuals and businesses had wells drilled and windmills installed to provide for their own water needs. Public wells and windmills provided free water for people and draft animals, the locations often being the centers of commercial streets. In the East, and this is Cambridge, Massachusetts, in the East, windmills sometimes were mounted on the tops of multi-story buildings to pump water into wooden reservoirs from which it flowed by gravity to the users inside and for fire protection. Resorts, which brought the luxuries of urban life to rural areas with scenic beauty, often had windmills pumping fresh groundwater for guests and employees. I have sinned. I'm about to purchase an indulgence. My intermediator is right there. The market for windmills in the United States began softening with the introduction and increasingly widespread use of small internal combustion engines starting in the 1890s. Windmill production continued on a large scale, but the small gas engines suggested that consumers might not always choose machines that were dependent on the fickle wind. With an internal combustion engine burning a fossil fuel like gasoline or kerosene, a farmer or rancher could pump water, grind grain, or cut firewood any time that he chose. The demand for windmills, however, changed more dramatically with the introduction of inexpensive electrical power available in the countryside from the Rural Electrification Administration and its cooperatives starting in 1935. With electricity, farmers and ranchers connected to the High Line could pump water, grind grain, saw wood, and do innumerable tasks cheaply and conveniently. Those who lived distant from power lines often chose small wind generators to produce at least enough electricity to illuminate a few incandescent light bulbs and operate radio receivers for home entertainment. During the economic depression of the 1930s, the windmill manufacturing industry entered a decline from which it never fully recovered. Rationing of strategic materials during World War II and the 1940s made it difficult for most makers to produce windmills, and most of them shifted to contracts producing war materiel. The factories in the Fox River Valley in Illinois and elsewhere, which already had machines to shape brass tubing into pumping cylinders, for example, became makers of brass-cased artillery shells. After the close of the world conflict, the market for windmills returned, but never at pre-war levels. Company after company changed to other products, became wholesalers of water supply goods, or simply went out of business. A handful of the old companies held on to the trade that remained, and several survive to this day. There are these and a few new firms and importers continuing to this day to supply new windmills to buyers who live remote from electric power or who still find it profitable or desirable to use the free power of the wind rather than fossil fuels. Batavia remains known today as having been a center for the design and production of windmills. Windmill manufacture began in the 1850s and 60s in small metal and woodworking shops, many of them just a single room. The pioneer makers here and elsewhere contracted with foundries to produce iron castings, which they smoothed and machined, adding other wooden and smaller metal pieces to produce complete machines. As the volume of production increased, successful manufacturers by the 1860s expanded into entire factories with multiple departments, producing windmills with interchangeable parts for mass markets. The typical windmill factory in the late 19th century included such distinct departments as offices, pattern making shop, foundry, machine shop, woodworking department, sheet metal department, assembly shop, and shipping department. The workforce in windmill factories consisted predominantly of men. The handful of women found positions as stenographers, bookkeepers, and the like in the offices. Massive immigration from Europe in the latter 19th century provided workforces for the factories. In the Fox River Valley, for example, many of the workers were of Scandinavian and Germanic origin. One of the companies in the area even named some of its windmills the Terrible Swede and the Flying Dutchman. Photographs of workers in the windmill plants often suggest national origins. Boyish faces show how early many started their lives of labor. Every windmill factory either had or aspired to have its own foundry. There, furnaces heated metal to liquid form so that it could be poured into molds to make cast parts right on the spot. It enabled a company to produce its own iron castings when needed, as well as to make repair parts when their own machines broke down. In producing castings, workers first made full-size wooden patterns of the parts required. They then used these patterns to make molds in wooden frames containing special casting sand. You see those molds here in the foundry at the Challenge factory in Batavia. I promise I didn't do that. Let's go one more. Molders poured red-hot molten iron into the molds. After the metal cooled, foundry workers passed the iron parts to others to smooth and prepare them for actual use. If the company could not afford the convenience and savings of having its own foundry, it paid other firms to produce castings under contract arrangements. Machinists that you see here use special machines to grind away imperfections on rough iron castings. Excess metal often flowed into cracks in the molds or created other rough edges on the parts. In larger factories, men took the smaller iron parts to an area known variously as the mill room, the tumbling room, the rattle room. There, they put the loose castings into rotating tumblers with wear plates and iron balls. As the cylindrical devices turned, imperfections, burrs, and excess metal wore away. All the detached iron went back into the furnace to be melted and used again. In smaller factories without tumbling machines, all the rough castings went directly into the machine shop. The machine shop proper was the key department in every windmill factory, where skilled workers did much of the precise work. These generally well-paid men used special grinders to remove imperfections from castings, smooth cast iron gears, cut steel gears, milled shafts, cut keyways, prepared bearings, and did most of the exact work in the plant. Many larger factories had separate and distinct blacksmith shops that provided maintenance and repair service for the entire complex. In the early decades of windmill manufacture, the woodworking department played a major role in production. Here, workers converted large wooden timbers into windmill wheels and vanes and produced prefabricated wooden towers and water tanks. Everything in the woodworking shop was designed for cutting, making it a dangerous place to work. The sawed and assembled wooden parts went next to the paint room, where most were dipped in order to give a finished appearance and a measure of protection from the elements. In time, the demand for wooden windmills around the turn of the 20th century decreased as all metal machines took their place. This meant that the sheet metal department supplanted the earlier woodworking shop in importance. In this newer area, highly skilled laborers cut galvanized sheet steel and shaped it into blades, vane sheets, and hoods. They also cut angle steel into vane stems and wheel arms, while at the same time cutting and punching angle steel and other metal material to create prefabricated towers. Some of the larger companies had their own galvanizing plants to give steel parts weatherproof zinc protection, while smaller firms used steel that already had been covered with molten zinc. From the various areas of the factory, parts converged at the assembly and shipping departments. There, the elements of windmills, towers, tanks, pumps, and other pieces of associated water supply equipment came together. Workmen crated and bundled the parts and pieces for shipment. I didn't do it. As orders came in from distributors, goods were wheeled onto wooden or concrete platforms and loaded into boxcars for railway shipment to customers. Even before factory workers loaded new windmills into railway cars for shipment, the work of the marketing department had preceded them. Some of the best minds in the industry focused on sales because these sales led to profits. The front line for marketing was the traveling salesman. On the road, going from town to town, these traveling men visited farm implement dealers, hardware stores, lumber yards. They distributed sales literature and promoted contracts for the companies that they represented. Sales staff assembled commercial exhibits at county and state fairs. Here the companies erected tents to shelter and welcome customers while pitching the merits of their particular lines. World's fairs in the late 19th and early 20th centuries became the sites for the most spectacular commercial exhibits of windmills. The largest of all these displays sprang up beside a lagoon. They wished it was a saloon. on the grounds of the World's Columbian Exposition in Chicago in 1893. Farm Implement News on the 12th of October, 1893 declared, numerous tall towers, like the masts of ships grouped closely in harbor with colors flying, surmounted by wind wheels of various forms and sizes, whirling in the bright sunlight and throwing off sparkling rays of many colors, afford from the distance a unique, lively, and brilliant spectacle. This description was no exaggeration. And here, the exhibit of the Challenge Company of Batavia. You begin to see this truly was big business. By far the most common forms of promotion were printed advertisements and trade literature. Manufacturers targeted some advertisements at actual consumers, but directed most of their marketing budgets toward potential dealers. Company participation at conventions and other gatherings of dealers became necessary elements of the marketing programs. Such meetings gave the sales staff the chance to meet personally with dealers and put sales literature and catalogs directly into their hands. Once windmill makers created wholesale relationships with distributors, the business agreements might last for decades. Some companies adopted different strategies to promote their goods. Although most manufacturing firms sold windmills, towers, pumps, and auxiliary goods only to dealers, a handful of firms during the early 20th century sold directly to customers. They actively marketed windmills directly from the factory to buyers, typically within about 50 miles of their plants, near enough for farmers to come there in their wagons or their early motor cars. A number of mail-order firms also distributed windmills. They contracted with bona fide windmill manufacturers to produce mills marketed with their own brand names. In this way, Sears, Roebuck and Company sold Kenwood windmills for decades, while Montgomery Ward and Company distributed Clipper mills. Some smaller mail-order catalog companies also had their own windmill lines. As people began enjoying life with windmills during the latter half of the 19th century, they needed service people to erect and care for them. Often dealers erected themselves or contracted others to put up customers' windmills. Many well drillers simply added windmill installation and repair onto their regular line of work, sinking wells and repairing pumps. On the big ranches in the American West, owners delegated responsibility to specific employees for maintaining sometimes dozens of windmills. These men spent their work hours riding across the expanses of pasture, going from windmill to windmill, endlessly greasing and often repairing them. A class of workers, these service providers came to be known as windmillers. Farmers typically took care of their own windmills unless repairs were too complex for them to undertake themselves. Almost all the older wooden wheel and open-geared, back-geared steel mills required regular lubrication, often weekly. It was not unusual for the sons in families to be assigned this duty as soon as they grew old enough to climb the towers. There are probably people in this audience who did this as boys. This work presented no great difficulties during pleasant weather, but became hazardous during high winds or when ice and snow covered the ladders and service platforms. Repairs might be as simple as tightening loose bolts. Other times, however, workers replaced worn bearings or gears, repaired wind-damaged wheels and vanes, and even replaced broken main shafts. Frequently, maintenance had to be given to the piston displacement pumps located underground at the water table. Actuated by the wooden pump rods that extended downward from the windmill, these pumps pushed the water up the pipes to the surface. When the leather seals became worn, service providers had to lift out the pumps to replace these gaskets. Some of the heaviest work for windmillers involved erecting new machines. Laborers began these jobs by excavating by hand anchor holes into the ground to secure tower legs. The minimum depth for these anchors was 5 feet, all dug with picks and shovels. The laborers then erected the towers, using one or the other of two methods. When it was practicable, the windmill erectors assembled the towers lying on the ground and then used cables drawn by animals, motor vehicles, or hand winches to raise the derricks into a vertical position over the wells. When space was limited or unusual height of a tower precluded this former method, crews built the towers up one piece at a time. In this method, workers employed gin poles to lift the windmill components to the tops of the towers in order to put them together. Over time, the number of trained windmillers began to decline. To deal with this situation, in the late 1970s and early 80s, schools such as New Mexico State University in Las Cruces or Angelo State University in San Angelo, Texas, began offering short courses in windmill technology, training new generations of erectors and repairers. Today, the American Wind Power Center in Lubbock, Texas, continues to offer these training courses for those who would like to learn how to provide practical windmill service. B.H. Tex Burdick Sr. of El Paso, Texas, was one of the most famous of the old-time windmill men. Many windmill enthusiasts today are familiar with Burdick from the spectacular photographs that he made from the 1920s to the 1940s, illustrating his employees in all types of windmill work that later were published by Texas Tech University Press in the Blades in the Sky book. Through the decades, Burdick was a major customer for the Challenge Company of Batavia, purchasing its windmills and steel towers by the railway boxcar full. For many people, the first thoughts of windmills are of lonesome towers standing on windswept cattle ranches. Pumping for livestock was one of the first applications of factory-made windmills in North America in the 1850s. This role of wind power has continued important to the present day, and there are still many areas remote from electric power where windmills truly by the thousands still elevate water for stock. Windmills were instrumental in making ranching possible in western areas of the United States and Canada. Wherever water could be found underground, wells and windmills could make it available for users. This ability to have water where one wished, or at least where one could afford it, meant that ranchers by the 1870s and 80s could begin dividing their properties into pastures with inexpensive barbed wire fencing. For many stock raisers, this combination of drill wells, windmills for pumping, and wire fences allowed controlled breeding of their animals for the very first time. A typical pasture water system consisted of a windmill over a drilled well, an open-topped round metal or wooden reservoir with low sides, low enough to allow cattle to drink, and an overflow pipe carrying excess water to an earthen pond. Ranchers often ran their windmills 24 hours a day, turning them off only when necessary for service. They pumped water as long as the wind blew. It was consumed by animals, evaporated, or sank into the ground at the overflow ponds called stock tanks. The constant operation meant that the older ranch windmills required regular lubrication, normally weekly. And this situation led ranch owners to employ men who devoted their time exclusively to windmill maintenance and repair. Windmills served as important landmarks on the plains. They sometimes even doubled as lighthouses, as ranch wives occasionally climbed the towers in order to attach kerosene lamps so their husbands and other family members could find their way back home across the prairie after dark. Wherever travelers might go on the plains, they knew that windmills dotting the horizon represented places where water could be found. Probably more windmills were used on farms than anywhere else. From the 1850s onward, thousands upon thousands of windmills left factories, mostly in the Midwest, for sale to farm families across the country. There, the windmills typically elevated groundwater for both humans and animals. The elemental farm water system was a drilled or dug well over which a windmill stood on a tower. In the simplest such systems, water from underground might pass through open troughs from which humans dipped and animals drank, with the overflow passing into an earthen stock pond. In slightly more sophisticated systems, windmills pumped water into elevated storage reservoirs from which the family could release the flow by gravity through pipes and faucets. Any overflow passed to open troughs and then into the earthen tank for animal use. Oops. More sophisticated farm water systems used float valves connected to windmill regulators. These devices turn windmills off and on automatically when storage reservoirs filled or emptied. In colder parts of the country, some farmers placed elevated reservoirs in the attics of their homes or in the lofts of their barns. In these locations, heat from the residents and the animals kept the reservoirs and pipes from freezing in the wintertime. Some agriculturists applied windmills to irrigating their crops. They excavated earthen reservoirs, heaping up the soil at the edges, and allowed the windmills to pump groundwater into them around the clock. When the time came to irrigate intensively cultivated fields of fruit or vegetables, they released the water through open channels to reach the crops. Windmill irrigation experienced a flurry of interest during the 1890s, but other methods supplanted the wind for irrigation in the decades that followed. Even though windmills have not been used for serious crop watering for a century, the land still shows the marks of circular and rectangular reservoirs excavated to hold windmill-pumped irrigation water. If you've ever flown up the Platte Valley, for example, you can spot the earthen banks from these historic reservoirs really easily. Schools used windmills in rural areas. Without water from other sources, schools often had their own wells and wind machines to pump water for pupils, teachers, and the animals that transported them to the classrooms. Windmills served a number of unexpected functions on farms. Owners often stocked windmill-filled ponds with desirable fish, giving their families food variety on the dinner table. In northern states, the same people, these same ponds form layers of ice in the winter that some farmers cut and stored for use during the warmer months. Children enjoyed skating on the ice before it was cut. During the summer months, ponds were used for swimming and even boating. Many people, including me, learned to swim in such ponds filled with groundwater. Not all windmills came from factories. A few wind power users in the 19th and 20th centuries constructed their own homemade machines to use the free power of the wind. These devices were not necessarily so efficient as those from the factories, and they often lacked any governor to regulate their speed to protect them during windstorms. They did compete successfully with factory-made windmills, however, on the basis of economy. Some of them were incredibly cheap to build. The simplest of the homemade windmills consisted of rectangular wooden boxes that had 4, 6, or 8 paddle-shaped blades exposed to the wind where they stuck up above the edges of the boxes. You can read the stenciling from the wooden packing crates for Arbuckle's coffee. More sophisticated were the battle axe mills. These employed towers similar to conventional windmills, but had wheels comprised of large paddle-shaped blades. A number of farmers duplicated the principles they saw in factory-made windmills. They used basic materials of wood and scraps of metal to replicate designs they observed in mass-produced machines. A handful of the homemade mills had vertical axes and horizontal wheels. Some of these machines had circular metal tracks to support the blades, which usually were hinged on their outer ends. During the 1930s, another style homemade windmill made its appearance. It also consisted of second-hand components, this time cast-off 55-gallon steel drums and the differential gears from wrecked motor vehicles. Builders turned the differentials upside down at the tops of towers where they became vertical axes which supported cut-in-half steel drums mounted on arms. These grassroots inventions demonstrate the ingenuity of rural people and using resources readily at hand. One of the most important requirements for the operation of steam railways was pure water supply. Steam locomotives needed water to run, and it had to be clean in order to avoid building up scale inside of the boiler tubes. Locomotives stopped repeatedly to take on replacement water as they traveled. This meant that railway companies spent substantial sums to provide clean water at appropriate intervals along the tracks. In the East, railroads generally were able to find surface water easily. As they laid rails westward onto the Great Plains and beyond, the need grew more acute as the land grew more and more arid. Surface water was often unavailable, while it cost railroads substantial amounts of money to buy coal and then haul it to remote locations to feed steam pumps. Windmills offered a viable option for elevating the water that the firms needed. By the 1870s, railway companies started using increasing numbers of windmills to pump groundwater for their steam locomotives. In response, manufacturer after manufacturer produced large diameter, heavy-duty mills termed railroad pattern. These were of substantial construction and in sizes up to 30 feet in diameter. Many of the manufacturers also produced or sold large wood stave water tanks that came with special spouts to fill locomotive tenders quickly. The mills pumped most of the time to keep the tanks filled and ready at any time to water locomotives. The large diameter mills and elevated tanks became common sights along railways in many parts of the country during the late 19th and early 20th centuries. I do want to advance, I'm sorry, pardon me. Some municipalities also employed railroad pattern windmills for domestic water supply, while some ranchers also used the big mills for deep or large volume pumping for livestock. I think that I advanced one too far. Let's go forward one. I'm so sorry. As soon as windmills began appearing on farms and ranches in the 1850s and 60s, people started putting them up in urban settings. Initially, individuals erected windmills to pump groundwater from drilled or hand-dug wells at their homes or at their places of business. Then, municipalities began placing windmills over public wells so that residents and visitors could secure clean water. Eventually, some communities constructed entire waterworks systems in which windmills pumped water into central reservoirs from which it flowed through pipes to the consumers in the towns. Communities in time constructed more sophisticated waterworks systems, and power pumps supplanted windmills when demands for water outstripped the supply that traditional windmills could provide. Yet, many individuals retained windmills and private wells instead of using city water or as backup sources should the central systems break down. To this day, windmills remain to be found in towns in many parts of the United States. Resorts transplanted urban life into scenic rural settings. From mountaintops to seashores, developers of these facilities found that windmills represented a practical means for pumping water into elevated reservoirs. The pressure of gravity forced water from the tanks through pipes to where guests and employees could use it for drinking and washing. In some instances, resort operators also used power windmills to grind grain for horses and other animals, and in later years employed wind generators to produce limited amounts of electricity. As early as the 1860s, American companies had begun exporting factory-made windmills to overseas markets. American-made windmills found buyers around the world. By the boxcar load, they went to ports for ocean shipment to other lands. To this day, U.S.-made windmills survive by the thousands in areas like Southern Africa and Australia. This is a Batavia-made Halliday standard at Port Dauphine on the island of Madagascar in the Indian Ocean. No sooner did overseas dealers start selling imported American windmills than local people in these countries abroad saw that money could be made producing windmills themselves. In this way, factory-made turbine wheel windmills came to be used, at least to some extent, in most countries around the world where the wind could be exploited to lift water and to do other human work. Today, the largest windmill factory in the world operates in Buenos Aires, Argentina. Let's come back to Batavia. What about the role of this place in the significant history of manufacturing wind machines? There's no question of the important position of the windmill city and the growth and development of this enterprise that helped transform the American West into a productive region. You'll learn after lunch from Christopher Gillis how some of the technological innovations made in Batavia ended up being the first used anywhere by a different company. Important concepts that effectively changed the design of virtually every subsequent water pumping windmill produced in America and elsewhere in the world. Then, Bob and Francine Popick will describe the legacy of the Batavia manufacturers and explain how you can play a role in preserving this significant part of community heritage. Thank you so much, and thank you for your patience with this device. I'd like to open up the floor for comments, questions, observations. Yes, please.
That pumping clean water out of the ground for the steam engines, wasn't there a problem with hard water?
Absolutely a problem. Absolutely a problem.
How did they prevent the...
At this point in time, there were really not very effective processes to deal with it. Sometimes the well might be at some distance, and if it was in a higher location, they could put in a line with gravity feed water to the side of the railroad tracks. I do know that they simply, if possible, go 5 miles away where perhaps there were not as many natural pollutants. More questions? Yes, sir.
What do you consider the most significant thing to progress in the West? Was it the barbed wire or the windmill?
There was a three-way partnership that allowed Euro-Americans to move west onto the Great Plains. And it's an interesting combination. You have first, since we're talking about windmills, drilled wells and windmills, which are actually two technologies that operated hand in hand. The second was inexpensive barbed wire fencing that allowed stock raisers to restrain grazing animals from their crops. And the fourth was the revolver, which allowed Euro-American settlers on the Great Plains to defend themselves from raiding nomadic Plains Indians. And to give you an example, a Comanche warrior, the Comanches had the reputation for being, with the Cossacks, the greatest horsemen in human history. A Comanche warrior riding bareback with 1 foot over the back of his pony, leaning behind the body and the neck of the horse, could keep 10 arrows in the air at one time. These were incredibly formidable warriors. And Euro-American settlers and Afro-American settlers from the East who had single-shot muskets could not effectively protect themselves from warriors who could shoot that many arrows with accuracy at one time. And the revolver made it possible for them to defend themselves, because at least you had 5 shots, or later 6 shots, before you had to stop to reload. So windmills and drill wells, barbed wire fencing, and the revolver together made it possible for Euro-Americans successfully to move out onto the Great Plains.